Hello, everyone. Your math joke for today is, why was the math book so sad? Because it had so many problems. Okay, let's dive into our new unit, Unit 3. So on your table of contents, make sure you write Lesson 3.1, Algebraic Expressions. And then I printed off the notes page so we can start there. Now recall, the title of this is expressions, meaning that it's not an equation. If you remember, an equation and expression are a little different. Equation has an equal sign. Equation, equal. Expression has no equal sign. So expression, there's no equal sign, meaning we can't solve it. We can't find out what the answer is. We're just going to focus on simplifying. If there is an equal sign, you can solve it. You can find the answer. So in an expression, you may see an expression like this: 2x plus 4. And there's different parts of that expression. We want to recall these vocabulary terms. Hopefully you've heard these before, but let's write them down. The first one is terms. So this expression has two terms. The terms are 2x and 4. So terms are 2x and 4. And terms are those numbers or letters separated by an addition or subtraction sign. Or you can think of it like little groupings, like here's a term, here's a term. They're separated by the addition sign. Some other things are the coefficient. You should have seen this in the entry ticket reviewing this. 2 is the coefficient here. Remember, coefficient is the number in front of the variable. It's that multiplier. Or 2 multiplied by something, so 2 of those x's. Now the x is, like we said, the variable. And remember, variables can be any letter at all. X is just the most popular one. It's going to be a letter representing one or more numbers. And we're going to dive into the or more numbers at the end of this unit. And the last one is, remember what constants are. Again, this was on your entry ticket. The constant here is going to be 4. And that is a term that does not have a variable, a term without a variable. It's just a lonely number. So those are your 4 big vocabulary words that we will be using quite a bit this unit and going forward this year and next year as well. The other thing I want you to recall is the distributive property. So you learned this in 6th grade, but I know some of us actually jumped over 6th grade or don't remember, so I wanted to refresh our memories. The distributive property means to multiply the number on the outside of the parentheses by everything on the inside. So let me show you how this looks. You might have something like 6 multiplied by the quantity, that's how you say a parenthesis technically, 6 multiplied by the quantity of n plus 7. This number is out front. It's our coefficient to this value. And so we want to make sure we multiply it to everything on the inside. So we draw these little arcs. So we're going to do 6 multiplied by n. That'll be 6n. 6 multiplied by 7. That would be positive 42. And then that would be your simplified version, because you're having 6 of these items. So you distribute the 6 to each term. That's why it's called the distributive property, because you're distributing that multiplier, that coefficient. Let's look at another one. It could be 5 multiplied by the quantity of 6m minus 8. We need to distribute that 5 and multiply it. 5 times 6m. Okay, so that's 5 6m. So 6m and 6m and 6m 5 times. Or 5 multiplied by 6 is 30 m's. The m just comes along. You multiply the coefficients. 5 multiplied by negative 8, that'd give us negative 40. So there's the simplified version, 30m minus 40. And that's really going to help us with our next few lessons where we have to start solving things. That's when we get to equations, though. So let's go down here and take a look at some examples. So like terms, again, something you learned last year, but I want to make sure we covered it. So like terms are terms. Remember what terms are. Terms are anything separated by addition or subtraction signs. Terms with the same variable and exponent. So let's look at that. Down here it says identify the like terms in each expression. Well, if you have two colors, that will come in handy today. So we need terms, the same variable and exponent. Well, I see we have a 9x and a negative x. So I'm going to circle those in red. Make sure you always include the sign in front. You don't want to lose that addition or subtraction sign, because really that tells you if it's a negative or positive as well, remember. And then we also have some constants, which are like terms. That's going to be our negative 2 and positive 7. So we can separate these to show that negative 2 and 7 are like terms. And then also 9x and negative x are like terms. There's our groups of like terms. Go ahead and pause the video and try the next one on your own. Okay, let's see how you did. So this one we have exponents, but we have a z squared here and then a z squared over here. So those are like terms. Make sure it's a negative 3z squared. And then we also have terms that just have a plain z, positive z and positive 5z. So our like terms are 5z and z, and the other one is z squared and negative 3z squared. And the reason you want to be able to group terms together is so we can simplify these, because an algebraic expression is in simplest form when it has no like terms or parentheses. So meaning that everything is combined. There's nothing left that could be combined or simplified to be smaller, which is going to help us when we're solving equations, which is why all these concepts are really important in this lesson. So when we're simplifying algebraic expressions, you want to first apply the distributive property if there are any numbers directly in front of the parentheses. So similar to what we looked at before, where we had 6 multiplied by the quantity in parentheses n plus 7. Then step 2, identify and organize all like terms, just like we did on the last two examples. And step 3 would be to combine all like terms into one single term by adding them. Or subtracting, depending on how you write it. Because remember, subtraction problems can also be written as addition problems. Okay, so let's take a look. First one. So I don't see any parentheses, meaning there's no example of a distributor property in here. Next step, we need to identify and organize the like terms. So let's go through with our colors. 7 is first. Is there anything else that's just a number, just a constant? Oh, -5. And that's it, because everything else is variables. Okay. How about the +4p? Does anything else have a p? Oh, right here. This has a p. And that's it, because this one is the only one that has an x. So let's go ahead and organize those then. So I'm going to put 7 and -5 here. And then also I have +4p and a +p. And then I'll bring down my 2x. So now I've organized it so that way I have my like terms grouped together. This makes it really nice for step 3 when we combine all the like terms into one single term by adding or subtracting. So for instance, 7 minus 5, that can be simplified. 7 take away 5 is 2. And then 4p plus p. So think about p for penguins maybe. You have 4 penguins and you're adding another penguin. How many total penguins do you have? 5 penguins. And then we have the 2x. And that is our final answer, the most simplified version of our expression. Again, this is going to be really, really helpful once we start solving equations and it gets more complex as the unit goes on. Let's try another one together. So this one, let's start off by saying, is there anything with the distributive property? No parentheses. So nope, no distributive property here. Let's go ahead and start identifying, organizing our like terms. So we have 3/4 y. Anything else with a y? Oh, yep, right here we have a -1/2 y. And then we also have a +12. Anything else that's just a lonely number? Yep, -6. And let's go ahead and organize that. So we'll rewrite the equation. 3/4 3y. Almost looks like a 4. 3y. 3/4 y. And that -1/2 y. And then we bring down our constants. +12 minus 6. Now we can combine those. Notice we are combining fractions. Well, we have to think back to the last unit. In order to add or subtract fractions, we need to have them have common denominators. Well, if I multiply this one by 2, then I can make it a 4. So I'm going to multiply the top and the bottom by 2. So then that becomes 2/4 y. I'll bring down my 3/4 minus. So now I know, okay, 3/4 y minus 2/4 y. So now I know it's just 3 minus 2, right? The 3 minus 2 over 4y. And 3 minus 2 is going to be 1/4 y. Okay, let's look at the green ones. 12 take away 6. Well, that's straightforward. It's going to be 6, right? So now we need to put, or +6. Now we need to put those together. Our answer is 1/4 y plus 6. Okay, we have 2 more problems on the back of this page. Go ahead and pause the video. Try those on your own. Whoop. Where's my paper? There it is. So go ahead and pause the video and try this one on your own. Okay, so notice this one did have parentheses. We need to first distribute. So we will be multiplying this -2 to both of the terms inside the parentheses. So that's going to end up being -2 multiplied by g, which would be -2g, and -2 multiplied by 4, +4, which is going to end up being -8. Remember, a negative multiplied by a positive gives you a negative. And then we just bring over what's left, plus 7g. Now we can proceed like normal. Let's find our like terms. Well, the first one is a -2g, and here's another one that has a g. And then we have a little -8 that doesn't have any like terms to go with it. So let's rearrange these, -2g and +7g, and then bring down our -8 or -8. -2g and 7g. Well, we have -2 of something plus 7 of something. If you combine those, it would end up being 5g, right? We have 7 of something and we're taking away 2, we're adding 2 negative. So it's going to give us a 5g. Bring down -8. There's our answer. Okay, go ahead and try this next one on your own as well. Let's take a look. Again, we need to do the distributive property because there's a number directly in front of those parentheses. So let's think. -1/2 of 6n. Well, 6, what's half of that? 3, right? So we have 3n would be half of 6n. But remember, we want the negative half. So it's going to be a -3 because a negative multiplied by a positive is a negative there. -1/2 multiplied by 4. Half of 4 is 2, and this is a negative multiplied by positive, so it's going to be a -2. And then we bring down our +2n. Now we can find our like terms. So we have a -3n. Oh, and at the end we have an n. Oh, that was crazy. At the end, we have another n. So we have -3n and a +2n, and then I bring down my -2. Now let's combine our like terms. -3n plus 2n. So we're doing the -3 plus 2 to find out how many n's do we have. Well, remember -3 plus 2, that's going to give us a -1n. Bring down the -2. And this would be an acceptable answer. That's correct. But you actually could simplify it a little bit further. Because think about 1 multiplied by n is going to be n, or -1 multiplied by n would be the negative version of n. So this can actually be written as a -n minus 2. I'd be fine with accepting this version as well. This is just a more simplified version, and you will see that sometimes. They just say a -n and don't have that 1 there, because multiplying by 1 doesn't change anything. Okay, folks, make sure you tape this into your notebook, and please use these steps to complete the practice assignment. Make sure you do the practice assignment until you understand them all, and then once you got it, move on to the exit ticket. I did change the practice assignment a little bit, that you have unlimited attempts, so you can do as many times as you like, and it just tells you if your answer is correct or wrong. It doesn't give you the right answer, so that way it makes you keep trying and problem solving until you get that right answer. Okay, folks, if you need any help, let me know.